Hello everybody. Today we are doing 7.5, and that is solving polynomial equations which are in factored form. So kind of what we need to do first before we can even talk about solving is talk about what it means to be in factored form. Now we're not actually going to go through and really deal with finding factored form right now. That'll be a little bit later. But just to see the difference between standard form and factored form. Um, so a polynomial that is in factored form when it is written as the product of particular factors. So if you think of a number like 6, it could be written as 3 times 2 times 1. And the number 6 would be written in factored form if it was 3 times 2 times 1. So the same thing can be true with polynomial equations, where this whole thing in standard form, if I can, divide certain numbers out of it evenly, just like I can divide factors out of a number evenly, if I can do things like that to this this equation, then I'll be able to get it into standard form. Now, what I want you to notice is that this one right here in standard form is the same as this here in factored form. And how do I know that to be true? Well, if I take factored form and I actually do multiply them, just like over here, if I had 3 times 2 times 1, the factored form, if I multiply them all out, I get 6. And I know that that's my regular number. Over here, if I multiply the factors, I get x squared, I distribute to the x, and then I distribute to the 2. So I get plus 2x. And that was my standard form over here. Right now, going from this trinomial right here over to the one on the left, it might not be so apparent that they have anything to do with each other. But then once you look a little bit closer, you'll see, okay, 24. How does 24 relate to this thing? Oh, well, that's when I multiply negative 3 and positive 8, I get negative 24. X squared, where does that come from? Okay, well, that comes from when I multiply x times x. Okay, so it's like if I multiply FOIL and I distribute, I should end up with the same thing. But where does that 5x come from? Well, I did first to get x squared. I did last, negative 3 times positive 8, to get negative 24. So the positive 5 must come from when I do the inside and outside. Okay, when I do inside, I get negative 3x. When I do outside, I get positive 8x. The combination of these two things simplifies to the center term of this trinomial. So yeah, this is the standard form of this factored form. Okay, and we will discuss, how to get from standard form into factored form later. But for now, we just want to be able to recognize what factored form is. All right, when one side of an equation is a polynomial in factored form, and the other side is a 0. So let's say, I took this first one, x plus 2, and I said it was equal to 0. If I have an equation that looks like this, I can use the zero product property. To solve the polynomial equation. So I can solve this type of equation using something called a zero product property. The solutions of a polynomial equation are also called roots. They are also called zeros. They are also called X-Intercepts. Okay, we have a lot of different words which mean the same thing with these solutions to polynomial equations. So get familiar with the idea of roots, zeros, X-intercepts. Let's talk about what that zero product property is, because I'm sure the minute I said that you were like, I have no idea what that is. Please open my brain and pour this information in. So let's talk about what it means in words first of all. what it means is that when you have two numbers and they are multiplying each other and the answer equals 0, so two numbers multiplying and you know the answer is 0, one of them has to be a 0. There are no two numbers that multiply where one of them is not a 0 and the solution equals 0. Now algebraically, what that says is we're going to say those two numbers are a and b, so when a and b multiply and they equal 0, either that first term a was a 0 or that second term b was a 0, because there's no other way. One of them had to be. And that's kind of intuitive. You know, it's not like a really crazy thought or a really big idea that somebody came up with and said, you know, this is brilliant. But you know, being able to notice that and work with it and use it is going to be more of the challenge. So, you know, it's the idea that if I have 6 times something equals 0, that something has to be a 0. Two numbers multiplying, I don't know what the numbers are, but I know that one of them has to be a 0. Okay, so this can get extended to not just talk about single numbers, but to talk about polynomials. So in example 1 here, I have a factored form of a particular polynomial. This polynomial would be x squared plus 8x, but it's factored out a little bit. And what I'm going to do is I'm going to try and solve it. And I'm actually going to get two answers, because technically I have two numbers multiplying each other. Okay? I can consider x plus 8 to be one number because it's within the parentheses. If it's within the parentheses, it's going to get evaluated first, and once this is evaluated, then it would get multiplied. So this is one number, x, this is one number, x plus 8, and they're multiplying each other. By the zero product property, I know that when two numbers multiply, one of them has to be a 0 if the solution is 0. So either this first number right here is the 0. So either that x is 0, and that's that first number, and that's it, that's just the way it is, or the second number, x plus 8, equals 0. Which would mean that the x value would have to equal negative 8 if I subtract 8 from both sides. So there I have my two possibilities, my two solutions. And what you can do is you can go back and you can substitute these values. Substitute x equals 0 into this equation. When you solve it, it will say 0 equals 0. It will be true. What about x equals negative 8? If you put negative 8 into here, you will get 0 equals 0. The equation will be true. Alright, let's try it again with part B and see if we can't make it start to feel a little bit easier. I have two numbers here. I have one number and I have another number. This is x plus 6 as one number, this is x minus 5. These two numbers are multiplying and their product equals 0. So one of them, either x plus 6 has to be 0, or x minus 5 has to be 0. The first one is going to imply that x equals negative 6 when I subtract 6 from both sides and get x by itself. The second one is going to imply that x equals 5 when I add 5 to both sides and get x by itself. Okay, so this process doesn't need to be extremely long, doesn't need to be extremely complicated. I want you to do me a favor and try example 2. It's going to be a little bit trickier because there's a little extra to the problems, but it's the exact same process. Right? It's multiple choice. Once you're done with example 2, we can move on to our last example. Alright, so hopefully you didn't have too much trouble with example 2. And we're going to go on to example 3 now, which is going to be a little bit more of a application type problem. And what we're doing is looking at a fireplace in a home, and we're kind of modeling the arc of the fireplace with a parabolic or quadratic equation. That's what all of these things are that have these x squareds in them, or quadratic equations. And we're looking at the specific height of the fireplace over the width of the fireplace. So that's what this equation is telling me, is that the height is so high at a specific width, and all of these measurements are given in inches. Okay, so the x-axis. Where is the x-axis? Let's see, I'm going to highlight that. The x-axis, just to be absolutely clear that everyone can see it, is right here. And what I'm being told is that that represents the floor. Alright, so the floor is not all the way down here where the arrow points, but it's right at the x-axis. So find the width of the arc at floor level. Okay, it doesn't seem too hard. Basically what I need to do is I need to figure out, where does it touch the floor over here, where does it touch the floor over here, and what's the distance between these 2 points. Okay, basically if I find this intersection over here, this will tell me how far away it is from the origin, and all I need to do is double that, because these things are symmetrical. Or I find both intersections and just find the distance between the 2 points. So how do I find these points? Well, it's the intersection of the equation and the x-intercept. Now what did I say on the last page? That the solutions to these factored forms are called 3 things. They are called roots, they are called zeros, and more importantly, they are called x-intercepts. So that's what we're going to be using. We need to find the solution to this equation. We need to find those x values that solve this equation to find the x-intercepts. So let's take a look at it. Where is floor level? It says, hint, at floor level y equals 0. So if I take my equation up here, y equals -1/9 x plus 18, x minus 18, and I want to look for the value of x at y equals 0, I substitute 0 for y. Awesome. Now all I need to do is solve. Well, I have 3 numbers multiplying here. I have -1/9, I have x plus 18, I have x minus 18. What do I need to do if I want to just get all of the x's alone on one side? Because right now I have like a coefficient that's multiplying. I have -1/9. What would you do if you had, say, 3x multiplying on one side? You would divide by 3. So over here, I'm going to do the same thing. I'm going to divide by -1/9, which is the same thing as multiplying by -9. And luckily over here, anything times 0 is just 0. So it goes away on this side like I wanted it to, and on the left side it really doesn't change anything. From this point, I am going to let you take over. I have it set up in a way where I have 0 on one side and 2 numbers multiplying each other on the right. I want you to find the x values, and then once you've found the x values, interpret what that means for the solution we're actually trying to find. We're trying to find how wide this arch is at ground level. So given the solutions that you're going to get to this, what does that mean? And I'll check it over in class, and hopefully we can all get that. Good luck.